Hi, welcome to this video on differentiating with fractional powers. Okay, we've got a bit of a recap first on just whole number powers, some positive, some negative, just as a recap of how differentiating works. And remember that the general rule for differentiating is that if you've got a function in the form of ax to the power of m, when you differentiate it to find the gradient, so dy by dx, the power comes down in the front and multiplies, so you get ma, okay, x to the power, and your power drops by 1, so m minus 1. Okay, so generally the rule is bring the power down and multiply, and then take away 1 from the power, which is easy enough when they're whole numbers, a little bit trickier when they've got fractions in. Okay, so we've got 4 examples. If you want to pause the video and have a go at them, then that's probably a good idea. And then when you're ready, press play. Okay, so for the first one, so dy by dx, okay, we've got 4x cubed. So the 3 comes down in front and multiplies, and 3 times 4 is 12. It was x cubed. If we take 1 away from the power, it becomes x squared. Okay. Then we've got a minus. This 2, this squared, comes down in front and multiplies. So 2 times 3 makes 6. It was x squared. Now it's going to be x to the power of 1, and I can just leave that as an x. Okay. For this term here, which is a x, remember now, x on its own is x to the power of 1. So the 1 comes down in front and multiplies, so it stays as an 8. And x to the power of 1, when you take 1 from the power, becomes x to the power of 0. Anything to the power of 0 is 1. So the x part sort of just disappears because it just becomes 1. Okay, so rather than 8x to the power of 0, we just say it's 8 ones, which are 8. And then that number on the end, the plus 13, well, that's x to the power of 0. If you wrote it in, you don't need to do this every time, but if you wrote it in, there's an x to the power of 0 on the end, which is 1. But when you bring the 0 down in front and multiply, well, 0 times anything is 0. And so any number term, any constant, is just going to disappear when you differentiate. Okay, so our final answer would be 12x squared minus 6x plus 8. Okay, on to the next one. So dy by dx, there are other ways of writing that, but we'll stick to dy by dx for now. Okay, looking at our first term, the 2 comes down in front and multiplies, that gives us 6. X squared goes to just x. Oh, I've got another squared here, maybe I should have made that cubed, so let's change that to a cubed. Right, just change our answer. That's going to go to 9x then, and it'll go to x squared. So 3x cubed goes to 9x squared. Then we've got 9x squared, so that 2 comes down in front and multiplies, so that goes to 18. And it was x squared, now it's x to the power of 1, so just x. Then we've got an x with nothing in front, so if I put a 1 in front for now, and it's x to the power of 1 as well, so the 1 comes down in front and multiplies, so that leaves us with a 1, and remember the x just disappears off because it becomes x to the power 0, and so it's gone, and the minus 6 as a constant term goes completely as well. Okay, so 9x squared plus 18x plus 1. Right, we've got a few here with negative powers, and the thing to remember with negative powers is that when they come down in front and multiply, they will change the sign for the whole term. Okay, so if we look at our first term here, we've just got a normal cubed, so that comes down in front, becomes 15x squared. Okay, now then look what happens. This minus 1 comes down in front, so it multiplies the 3, it becomes minus 3, but because we've got this minus here already, that's actually going to go to a plus now. Okay, it would be minus 3x, so it's going to go to a plus 3. Okay, we were on x to the power of minus 1 to begin with, and if we take away 1 from that, we'll end up on minus 2. Okay, you don't need to rewrite that as over x squared, you can leave it in index form, that's absolutely fine. and here we've got a minus 2 as a power. So the minus 2 will come down. It'll change that plus 8 to a minus 16. So it swaps our sign to a minus 16x. We're on minus 2 to begin with. If we take away 1, we finish up on minus 3. Okay, and again, leave it in index form. You don't need to go back and rewrite that as a fraction, 16 over x cubed. I know that's what it means, but you can leave it in index form. And then the last one then, so dy by dx. So the 6 comes down and multiplies, so that's easy enough. That's going to give us 12x to the power of 5 when we take away 1 from the power as well. Right, minus 2 comes down in front, so instead of plus 5, it's minus 10. X to the power of minus 3, make sure you go the right way when you take away 1 from the power. Minus 3 comes down in front, changes our plus 2 to a minus 6, and that goes to a minus 4. And any number term on the end there, any constant member, that just disappears off the end when you differentiate. Okay, it does cause a problem when we integrate, but that's for another day. Okay, so hopefully you got all those right. So let's move on now to fractional powers. The rule is the same. Okay, so we're still going to bring the power down and multiply and take away 1 from the power. It's just a little bit trickier when you're working with fractions, especially if the fractions and the coefficients don't go particularly well together. So down here you can see we've got a third and we've got an 8, and that's not going to work very nicely, but we do the best we can. The other thing I'm introducing on this slide is slightly different notation. Sometimes rather than saying y equals, we say f of x equals, and you would have seen f of x at GCSE for transforming graphs. Okay, f of x means a function of x, like an expression or an equation that's in terms of x. Okay, it's just another way of writing an expression, but when we differentiate, whereas when it's y equals we say dy by dx, when it's f of x, the way we say we've differentiated is to put this little dash in here. Look, so f of x, when you differentiate it, becomes f dash of x, and then you write out your differentiated answer if you like. Okay, so just a different way of writing out your maths. Right, let's have a look at this first one then. So we've got y equals, so we're going to go to dy by dx for this one, because if it's y equals, you have dy by dx. Okay, so same rules as before. The 3 comes down and multiplies, so that goes to 6x squared. So that's not a problem. Right, now then, this power of a half, that's going to come down in front and multiply. And because it's the first one, I've given you nice numbers. So a half of 6, a half times 6 is 3. So that goes to a 3. And if we were on a half, so if I get a number line here, if we were on positive a half, there's 0. So we were on a half, a positive half, and we take away 1, where do you end up? On minus a half. Okay, so our new power up there is minus a half. Okay, I'll keep the number lines, it's going to come in handy on the next bit as well. So on the third term there then, we've got a third. So the third comes down and multiplies again and again. Because it's the first one, it's a nice number. So we've got to do 1/3 times 9, or if you prefer, 1/3 of 9. 1/3 of 9 is 3. Okay, x. This time then, there's 0. We started on positive 1/3 and we're taking away 1. Now if you're working in thirds, 1 is the same as 3/3, so we're taking away 3/3, so that's what happens when you take away 1/3. Then we take away another third, which gets us to minus a third. Then we take away another third, we're on minus 2/3. So our new power is minus 2/3. We started on 1/3 and we took away 3/3 because we were taking away 1. Okay, so you need to be a little bit careful with your powers as well. Right, let's get rid of this to make some room for the next one. If you want to pause the video and have a go at these at any time, that's a good idea. Okay, so we're in f of x this time. So f dash x to say that we are differentiating. So 4x to the power of 1 becomes 4x, sorry, just 4. The x to the power of 1 just becomes 1, so just 4. Right, our half needs to come down and multiply by 5. Now a half of 5, because we could work it out, I mean it's 2.5, it's not a bad decimal, but we try to avoid decimals because a lot of fractions don't make nice decimals. So as a sort of an unwritten rule, we try to avoid having decimal coefficients. We'd rather have a fraction. Okay. We could write 2.5 as a mixed number, but again, that's a little bit messy. Probably the best way of writing a half of 5, 2.5, is to write it as 5 over 2. Okay, so a coefficient of 5 over 2. Don't really like having a mixed number coefficient, just the same as we don't like having a decimal coefficient. So a half of 5 is 2.5. It is 2.5, but we don't like writing it. It is 2.5 a mixed number, but we don't like writing it. We'd rather have an improper fraction, 5 over 2. Okay. And then if we were on a half and we took away 1, we would be on minus a half for our power. And for this one then, there's a lot going on here. So it's minus a third that comes down and multiplies. So a third of 6 is 2. We were on minus 6, but we're bringing a minus down. So the two minuses are going to make a plus. So our sign is going to change to a plus. That's the sign is taken care of. 1/3 of 6 is 2, so that goes nicely. Now this time, if I draw a number line out, there's 0. We were on minus a third to start with. We've got to take away 1. So take away another third gets us to there. Another third gets us to minus 1. Another third, the nicest way of writing this would be to say minus 4/3. Okay, we were on minus 1/3. We took away 3/3. We're on minus 4/3. Okay, so we've gone from there to there. We've taken away 3/3 because 3/3 is equivalent to 1. Okay, a lot going on that last term, especially with the sign changing as well because of the minus power that came down, and we had minus and minus makes a plus. Okay, number 3, back to y equals, so dy by dx is our notation. Okay, we've got a minus power come down in front, so that's going to go to minus 8, and that's going to go from minus 2 to minus 3. Then we've got a minus, and that's going to stay as a minus because this is positive. The worst thing about this term is having to do 1/3 times 8, and that's not going to go nicely. Okay, 1/3 times 8. So 1/3 times 8, or 8 times 1/3. And the trick when you're multiplying a whole number and a fraction together is to just multiply the numerator and leave the denominator alone. So 8 times 1/3 is 8/3. And it's better to be improper top heavy anyway. So we go to 8/3 at the front. X. Now if we were on positive 1/3 and we take away 1, then that leaves us on minus 2/3. You can draw it out on the number line if it helps. Okay, and then our last term, let me get rid of this because it's going to get in the way. Our last term, so we're going to bring minus 2/3 down. So first of all, that plus is going to go to a minus. So let's change that. Okay, then we've got to do 2/3 of 4. So 2/3 times 4. Remember, just multiply the numerator by 4 and we get 8/3 again. Okay, so that's 8/3 as our coefficient, and this time our power, okay, we're on minus 2/3 to begin with. If you take away 3/3, so that goes to minus 3, minus 4, minus 5, so minus 5/3 would be our new power. Okay, because we're working in thirds, you take away 3. So take away 3/3. If you're on -2 to start with, that puts you on -5 by the time you finish. And then the last one, so we've got f of x, so our notation would be f dash of x. Easy enough first term, bring it down and multiply, that goes to -6x to the power of -3. Right, you've got to bring a quarter down. Now the sign is going to stay as a minus, but I've got to do a quarter of 5, or a quarter times 5, that is 5 quarters. So 5 quarters goes in front, x. Now if we're on 1 quarter, positive a quarter, and we take away 1, which is the same as 4 quarters, 1 quarter, take away 4 quarters is -3 quarters. And then for our last term then, so we're bringing -3/5 down to multiply, so that plus is going to go to a minus. We've got to do 3/5 times 4, so that's going to give us 12/5. Not a lot you can do with that. Sometimes they simplify and you can write the simplified version, but none of the ones on this slide have simplified. 8/3 isn't very nice, 5/2 isn't very nice, 5 quarters isn't very good, and neither is 12/5. So we've got 12/5 in front, x to the power of, okay, so we're on -3/5. I think I'll draw a number line for this one. So there's 0. We're on -3/5, and we've got to take away 1. So working in fifths, 1 is 5/5, so we've got to go to minus, so there's 1 of our fifths. I have to extend this out. Then we get to -5/5, which is -1. Then -6/5. Then -7/5. And lastly, we get to -8/5. Okay, so we started there on -3/5. We're taking away 5/5, which is 1. So we end up on -8/5. Okay, so that's how you differentiate with fractional powers. Okay, careful with negatives because it's very easy to miss the changing of the sign. Careful when you bring your fraction down and multiply by the existing coefficient, and be really careful dropping your power by 1, because when you're working in fractions that's very easy to go wrong as well.